Hi guys, Audrey here. So let's do the limit as x approaches 0 from the right of e to the x minus 1 to the power of x. Step 1, as usual, we want to plug in. And when we plug in here, we get e to the 0 minus 1 to the power of 0 from the right. Well, e to the 0 is just 1. So this gives me 0 to the power of 0. Yes, that is an indeterminate form, and it's one of our exponent indeterminate forms. So we have an exponent there, so that means we're going to do our e ln thing. So we're going to say this is equal to e to the limit as x approaches 0 from the right of natural log of e to the x minus 1 to the power of x. We're just going to highlight e here so that we don't forget it. And erase that arrow because I don't like how it looks. And then go down and just do our limit part. So we have the limit as x approaches 0 from the right. I'm immediately going to apply my ln rule. Remember, ln of a to the b is equal to b ln a, and bring that x down to the front. Okay, so now what happens? Now we plug in, and clearly I'm going to get 0 times ln of 1 minus 1. Now here we actually have to be really careful. Be careful, because, oops, this isn't ln of the absolute value, it's just ln. And I know that ln of 0 from the right is going to negative infinity. Ln of 0 from the left, well, ln isn't even defined there. That does not exist. So that means we've got to be pretty careful right here. We want to make sure that that ln of 1 minus 1 that we have is ln of 0 from the right. So to do that, I'm going to draw a little graph of e to the x, right? And I know that at 0, the value is 1 there. So if I'm looking at ln of e to the 0 from the right minus 1, I want to know, is the 0 in here 0 from the right or 0 from the left? So when I'm looking at 0 from the right, if I'm looking at these values right here, oops, as we get closer and closer, as my x values get closer and closer to 0 on the right side, those values are bigger than 1. So I can look at this as 1 from the right minus 1. So in other words, even though 1 minus 1 is 0, as we get closer and closer to 0, our values are going to be positive because that e to the 0 from the right is bigger than 1. So then I can say that this is 0 times negative infinity. Good. So can't apply L'Hopital's rule. Instead, we bring one of our functions to the bottom. Ask yourself, 1 over x on the bottom or 1 over ln e to the x minus 1? Which is better? Which is going to make L'Hopital's rule easier? Hopefully, it's very clear that we should be bringing that x to the bottom. So we're going to have the limit as x approaches 0 from the right, ln of e to the x minus 1, over 1 over x, which is clearly better than the alternative x over 1 over ln of e to the x minus 1. So now we've already checked that ln. It's a negative infinity, and we're going to have a positive infinity on the bottom because 1 over 0 from the right we know is positive infinity. Now we can apply L'Hopital's rule. So I get the limit as x approaches 0 from the right. Here I'm going to have e to the x over e to the x minus 1. Minus sign is in the wrong place. Over e to the x minus 1 divided by negative 1 over x squared. Okay, so we could plug in immediately, but we know that before we apply L'Hopital's rule again, assuming that's the thing that we need to do even, we should always simplify first. So we're going to start off by simplifying this thing. So we'll have simplify the limit as x approaches 0 from the right, e to the x over e to the x minus 1 times negative x squared. Well, if I were to plug in from here, I get that this is e to the 0, which is 1, over 1 minus 1, which is 0, times, well, x squared, that's just 0. So this is like infinity times 0. Well, infinity times 0 would imply that we should bring one of the terms to the bottom, or that we should change things. But what I can see is if I can just bring that x squared up top here. So in other words, if I think of this now, 0 from the right of negative x squared e to the x, that this is actually just 0 over 0. And at this point, I will now apply L'Hopital's rule again. So after I brought that x squared up to the top. Okay, so I could have applied L'Hopital's rule from here. Oops. From here. If I plugged in here, I would have gotten 1 over 0. I would have gotten infinity over infinity. But applying L'Hopital's rule from here, first of all, I have a quotient rule in the top. That bottom is just going to get more complicated. It actually wouldn't have gotten me anywhere. It wouldn't have been very helpful, right? So even though you can technically apply L'Hopital's rule there, and even though I'm eventually going to have to apply L'Hopital's rule again, simplifying first gets it into a form where L'Hopital's rule will actually get me somewhere. So I just want to stress again, after applying L'Hopital's rule, don't just immediately apply it again. Don't plug in immediately. Simplify first. So I'm going to apply L'Hopital's rule again. And in that numerator, I'm going to have a product rule. So we'll just remind ourselves of the product rule. So we're going to have the limit as x approaches 0 from the right of the derivative of the first times the second plus the first times the derivative of the second, all divided by the derivative of the denominator. And now, if I wanted to, I could simplify here. I could simplify by factoring that e to the x out. So I'd have negative 2x minus x squared over e to the x. And those e to the x's would cancel out. But I can already see just by looking at it that when I plug in, I'm not going to have a 0 on the bottom. I'm not going to have an infinity on the bottom. E to the 0 is just 1. So I could also just immediately plug in here, because I can see that I will get straight to that answer. So this is 0 minus 0, oops, 0 minus 0 over 1, which is just 0 here. So that 0 is not my final answer. We want to remember to not forget to bring the e back. So we got that 0, now bring back e. So my final answer here is the limit as x approaches 0 from the right of e to the x minus 1 to the power of x is equal to e to the 0, which is 1. So here, that 0 to the power of 0, that exponent of 0 is the thing that clearly won this battle. The answer is 1. All right. That's all. Bye, guys.